Welcome back to Unit 2, Chapter 5, Section 5.5. We learned how to do long division yesterday. Now we're going to learn how to do synthetic division. So our goal today is to use synthetic division to divide two polynomials, and also we're going to use synthetic division to factor a polynomial. You can also use long division to factor a polynomial as well. I just think once you see synthetic division, you want to use it whenever you can. So first off, synthetic division. How do we do it? Well, if you remember synthetic substitution before, it's very similar to synthetic division. They're actually the same thing. So synthetic division, how do we set this up? Well, first of all, synthetic division, if you're dividing by a trinomial, you cannot do it. It will not work. So how do we do synthetic division? Well, what we do is we take the part on the left, it's going to go inside the box. Well, the box, remember, for synthetic substitution is like an upside down division sign. And remember, from synthetic substitution, all we do is take the coefficients or the number parts, constant in case of 5, and we put those inside of the box. Remember, if we skip any values, like if it's just 4x squared minus 5, we'd have to put a 0x in. But in this case, it's 4x squared, negative 13x, and negative 5. All terms are accounted for, so we don't have to put any zeros in. Now, what goes outside the box is a little different. Before, we were substituting in a number. It said, find the value of a function value, f of 3. You put 3 outside the box. But we're dividing by x minus 2. So what goes outside? Is it minus 2? Well, here's how you figure it out. You take what you're dividing by, the divisor, and you say, okay, x minus 2 equals 0. What would make x minus 2 be 0? Well, the 0 of x minus 2 is positive 2. So that is what's going to go outside of the box. The 0 of the divisor. 0 of x minus 2. What makes x minus 2 equal 0? So now we do it just like we did before, and I'm going to notice I kind of wrote those numbers big, give us a little more room. I'm going to extend the box down a little bit farther, not a bunch, let's see a little bit more room. We start out synthetic division, just like synthetic substitution. We bring the 4 down. It's the same process. We're going to multiply 4 times 2. 4 times 2 is 8. That goes in the next line. Then we add negative 13 and 8. We add these counts. We get a negative 5. And then 5. We do negative 5 times 2. That's negative 10. Negative 5 plus a negative 10 is negative 15. Now before, our answer was negative 15. That's just what our answer was. We circled it. We're not looking for what is the value of x equals 2. We're looking for the value of, or what is it when we divide these two polynomials. So here's what our answer would be. X squared divided by x, that's going to lower the exponent value by 1. So it's going to end up being 4x minus 5 plus, this is our remainder. So it's not the solution, it's our remainder. Negative 15 out of, well, what did we really divide by? We divided by x minus 2. So for me, synthetic division is much easier. I know it seems kind of strange at first, but once you practice it a few times, you're going to choose this anytime you can over long division. Most people. Some people, no, they're going to stick with long division, but synthetic division is faster than long division, but the drawback is you can only use it when you have a binomial divisor, a linear binomial divisor. Trinomials and quadratics, you can't use synthetic division. You must use long division. So we still need long division, but that is synthetic division. Okay, rewind it if you need to go through it again. If you understood synthetic substitution, it should be pretty similar. The only last difference is how do we take these bottom numbers, the 4, negative 5, and negative 15, and turn them into an answer. Okay, so here's some stuff to write down. Factoring polynomials completely? The factor theorem that's in your book, it says if a remainder is equal to 0, then x minus k is a factor of a polynomial. So if we get a remainder of 0, we've proven that that remainder can be turned into a factor of a polynomial. Okay, so write that down. What does that really mean? Okay, what does it mean? Well, let's apply it. Okay, example 1, says that it asks us to factor a polynomial completely given x minus 4 is a 0. So this is another way to factor a polynomial. If you're given a factor, or in the next time I'm going to show you if you're given a 0, you can find the other factors or factor the polynomial completely. So x minus 4 is a factor. So we're going to use synthetic division. Also, you could use long division, but I'm going to use synthetic division to see what we get when we divide by that factor. So we're going to do similar to what we did on the last slide. We're going to fill in the coefficients. In this case, 1x cubed minus 6x squared plus 5x plus 12. We don't have to put a 0 in. They don't skip any terms. X minus 4 is a factor, so what is the 0 of x minus 4? The 0 of x minus 4 is a positive 4. So that is going to go outside of our upside down division box. Bring the 1 down. 1 times 4 is 4. Negative 6 plus 4 is negative 2. 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. 4 times negative 3 is negative 12. Haha, we get a remainder of 0. The remainder is 0. That is just proved, which they told us it was, but it's now proven that x minus 4 is a factor. If 4 is a 0, then x minus 4 is a factor. So, what we've just done here, believe it or not, is started factoring this polynomial. X cubed minus 6x squared plus 5x plus 12 now equals, so we know x minus 4 is a factor, and now we know that 1x, well, started with cubed, 1x squared is a 1x squared minus 2x, excuse me, minus 3 is also a factor of the polynomial. So we factored, by knowing that x minus 4 is a factor, it allowed us to use synthetic division, or long division if you wanted to get the polynomial x squared minus 2x minus 3. If you use long division, you should, and you do it correctly, you should also get x squared minus 2x minus 3. So now, is it factored completely? Remember, that's the key word. We want to factor completely, not just almost factored. We want to factor completely. So that tells me we get a quadratic here, x squared minus 2x minus 3. Can I factor that anymore? Can we do bottoms up? So we're going to use bottoms up to factor x squared minus 2x minus 3. So bottoms up, remember we have a times c, 1 times negative 3, which is negative 3. What adds to make b, which is negative 2. So pause it, see if you can think of the combination. What multiplies to make negative 3 and adds to make negative 2? It actually is that combination of 1 times negative 3 and 1 plus negative 3. So we know that x squared minus 2x minus 3 is going to factor to x plus 1 and x minus 3. Notice in bottoms up, we divide by a. A is 1, so we're skipping dividing everything by 1 because that's not going to change our answer. But that's just factored the x squared minus 2x minus 3. What other factor are we forgetting? Well, we're forgetting the x minus 4. So our final answer has to have all three factors, excuse me, in the problem. So we have factored this now into 3 binomials using synthetic division. Okay, so how do we prove that we did it correctly? Multiply them back through. Use FOIL, use the table methods, whatever works for you. So now we're gonna do something very similar, but it's a little different. Now we're gonna find the other zeros. Zeros are solutions of a polynomial, and I'm also going to give you information in a little different form. Instead of saying x plus 2 is a factor of the polynomial, I'm telling you that f of negative 2 equals 0. What this means is, what this information right here is implying is that negative 2 is a solution. It is a 0. Okay, so f of negative 2, the function value of negative 2 equals 0 means the negative 2 is a 0. It makes the function equal 0. We're going to go through the same thing we did on the last example, just a little bit more at the end of the problem. Okay, so we start out the same way. 1x cubed plus 2x squared minus 9x minus 18 is the polynomial. We know that negative 2 is the solution, so there's no thinking about it. We just put negative 2 outside, and we do our standard synthetic division substitution method, whatever you want to call it. This time it's division. No. 1 times negative 2 is negative 2. 2 plus negative 2 is 0. 0 times negative 2 is 0. Negative 9 plus 0 is negative 9. Negative 9 times negative 2 is positive 18. Add them up, we get 0 for a remainder. That's golden. That is proven that negative 2 is indeed a 0. So what polynomial we have left here is 1x squared plus 0x, we don't need that, minus 9. That's the polynomial we'll have left. We already know that f of negative 2 is a 0. That means x plus 2 is a factor. Isn't that cool how that works? And then we say, can we factor x squared minus 9? Well, if we look, it's a quadratic, two terms, one subtracted from the other. That is a difference of squares model, maybe. Is x a perfect square? X squared a perfect square? Yes, it is. Is 9 a perfect square? Yes, it is. So we can factor this to x minus 3 times x plus 3. Remember, we're trying to find the zeros, though. But on the last slide, this would have been our answer right here. But that didn't ask us to factor. It said to find the other zeros, given f of negative 2 is a 0. So x, what we do with each of these factors then, we've done this before. X plus 2 equals 0. X minus 3 equals 0. And x plus 3 equals 0. We subtract 2. We already knew this one. We already had, this one was given. This is a given 0, so this is not new, but it is one of our zeros. This given 0 helped us find x equals positive 3 and x equals negative 3, also as zeros. How can we make sure that what we did algebraically is correct? Well, you can check this using your graphing calculator. Okay, so you get your calculator out. We're going to plug in the original equation, which was x to the third power plus 2x, x to the third power. Remember to hit right to get out of it, otherwise it puts everything superscript. Plus x cubed plus 2x squared. All kinds of issues right now. Minus 9x minus 18. Oh, y2 equals 0. That helps you find the zeros more easily. Let's graph it. Remember, the zeros are where it crosses the x-axis. It looks to me like it crosses at negative 2, negative 3, and positive 3. You can check that by going second trace, value. Let's plug in negative 3. Is that a 0? Yep. Second trace, value, positive 3. Is that a 0? Yep. I can go to the table. And at negative 3 is a 0. Negative 2 is a 0. And at positive 3 is a 0. Same as what I got before. Let's go back to the graph. I can hit second trace and go down to intersect and hit enter 3 times. There's a 0. I can do it again. enter twice this time, and then I'm going to arrow over, so I put y2 equals 0. I'm going to arrow over so I get close to my other 0 value. Hit enter, -2, which you're given. And then I can find the last one, hit enter twice, and I arrow over to the other 0, or at least closer to that 0 than the previous 0, and I find all 3. So we have proven graphically that our algebraic answer is correct. That's the key thing. The graph and algebra need to match up and be on the same page. If they are different, then you made a mistake somewhere along the line. Okay, so that's how we can use synthetic division to solve or to find the other zeros of an equation. So let's look back. Did we accomplish the goals we had in mind today? Hopefully you can say that you are able to use synthetic division to divide two polynomials and to factor and to solve. We did both. So using synthetic division to divide two polynomials, both to factor and to solve and find zeros, which that wasn't in the original target, but we kind of added to it. That's okay. So I have these notes down ready to go, and I'll see you tomorrow.